We're given a hexagonal grid filled with lots of small hexagons. We need to create fences starting from each number inside of the grid, and the length of the fences stemming from each number has to be equal to the number itself. Take a look at this example. You can see in the top left there's the number 7, and you can see in the solved version of this there's length 7 fences coming from it. After we've drawn all the fences, we need to create a shape. This shape can only turn 120 degrees at a time and touch all colors in the puzzle. It also must be symmetrical, either on a plane or rotationally. Let's take a look at the actual big puzzle piece now instead of just an example. You can see it's a lot bigger. Okay, so where do we start? One thing that you might notice about the big puzzle is that there's these two numbers in the bottom left, 38 and 19. These are really big numbers and will take up a lot of space if we draw out all the fences. So we probably want to start through here. Let's think about what the shape will look like. If it's rotationally symmetrical, we want to probably have a Z shape that tries to avoid the region with a 38 and 19. This is because in this region it'll be very crowded and it'll be hard to draw through it correctly. If it's symmetrical on a plane, we probably want a horseshoe shape that just dips around into the red and the purple symmetrically while avoiding all the clutter in the middle. Another constraint we need to keep in mind is that in order to draw a shape like in the example problem, we need to leave a gap of 2 when we're drawing our shape. This is because we need to leave one cell in order to go there and then one cell to come back in order to close off the shape. Let's take a look at an example of placing some fences and how crowded the bottom left side can be. Here's an example of placing 19 fences randomly, stemming from the 19. However, you can see, even if we stretch out the 38 now to as far as it can go while leaving the 2 space gap, as we said before, there's only places 32 out of the 38 needed fences. From this, we can kind of derive that the 19 isn't able to block off the 38 without it causing lots of trouble elsewhere on the map. Here's an example of the fences placed in a way that allows both the 19 and 38 to have adequate space to reach the red and the purple. It also leaves a bit of gaps around the edges. Here, I've done a few things. Firstly, since we know what the shape's going to look like, I've rotated the shape in order to adjust the plane of symmetry so it's more obvious with the plane of symmetry going from the bottom to the top. Next, I drew out some of the more obvious numbers. Like this 11 on the right, I'm trying to take up as little space as possible from the main path. And these 6s at the bottom, just fitting them within their quadrants. Then I started drawing the fence. You can see I want to try and stick with this shape as I mentioned earlier. Now that we've drawn one side, we can draw the other, based on symmetry. You may be wondering how we got these shapes, and the answer is a lot of trial and error. But eventually, as you're placing the fences and drawing the lines in this general horseshoe shape, you start to realize where things can and can't be. Now let's take a look at the 7 and 6 at the top. You can see they're in opposite sides of the same plane of symmetry. So if we draw a fence on one of the sides, on the other side we want to draw a fence in the opposite direction so that they're both negating the same squares. Here's an example of that. You can see on the left we went down into the left with the 7, and on the right with the 6 we went down into the right, because these squares, once they're blocked off on one side, we may as well block them off on the other side due to the symmetry rules. After that, we just try and take up as little space as possible with the other numbers while drawing the fences required. And this takes a bit of trial and error, and there's a few things you might notice, like, as I said, the planes of symmetry thing. We want to draw it into the direction of the plane of symmetry of things on the opposite side. Eventually you'll get something that looks kind of like this. You can see it's a bit wonky, but you can look at it and find ways to fix it up and then make it symmetrical. Here's the final result that we had. You can see to calculate the answer for the problem, you need to calculate the number of squares covered in the area of the shape. And I've tallied that up in the bottom left. Then you multiply these numbers together to get the final answer of 404,320. Thanks for watching.